Welcome to another episode of our podcast series by the European Integration Group. I'm your host, Aybars Öztuna, Global Partnerships and Fundraising Lead at the group. Today, we are delving into the frontier where engineering meets intelligence, the invisible architectures of modern technology that power everything from communication systems to AI sensors. Our guest is Urhan, a PhD researcher at ETH Zurich, specializing in electrical engineering and information technology. Urhan holds both his bachelor's degree from Hochschule Lausanne and his master's degree from ETH Zurich, where his thesis, High Resolution Lower Power Sigma Delta ADC, explored one of the most fundamental components of digital technology, the art of precisely converting the analog world into digital signals efficiently and sustainably. In this conversation, we'll explore his research journey, the culture of innovation at Swiss institutions, and how Europe can bridge engineering excellence with global technological leadership. Özcan, welcome. Thank you for your time. Before starting with the first question, I would like to briefly ask you how you spent your day. What's your day look like as a PhD researcher at ETH?
Thank you, Aybars, for inviting me to your podcast. That's actually a good question. I asked that myself as well every day. How should my day look like today? I do my PhD research at a research company in Switzerland called zcan, and it is at ETH where I'm enrolled as a doctoral student. So most of my research is at the company. So in the morning I usually go to the company. I work from there. I have my own desk. We have our labs. In the current phase that I am in, I work from the computer mainly. I am designing my concept models. I'm doing some simulations. I try to explore new ideas. That is often combined with literature research, of course. However, I still try to make contact with ETH, and that is actually very encouraged, where I also visit lectures and meet fellow researchers.
Okay, let's start with your core expertise, Sigma Delta analog to digital conversion. So for listeners outside the field, how would you explain why this technology matters in today's digital systems?
Actually, I would like to widen this a bit. It is not only Sigma Delta analog to digital conversion, but more in general, I work on sensor interfaces for modern sensors. As we all know, the physical world consists of mostly analog signals. So there is not a digital representation of the physical world. That is something that we want to build as engineers. Why do we want that? Well, information. For example, how cold it is today outside or how cloudy it is. We transduce that information from the analog world into the digital by using sensors and the sensor interface. The sensor interface does play a very critical role in trying to convert that information of the sensor into the digital domain accurately and without any addition of distortion or noise. Sigma Delta analog to digital converters are a type of sensor interface blocks which achieve high resolution for low bandwidth signals, for example, like temperature signals or pressure signals, something that does not change over time very fast. Rough intuitive explanation for how that works is we try to see what is the temperature right now, 20 degrees. If it rises up, we try to see if it goes up or down. And we do that over time. We accumulate actually all the ups and downs, all the lefts and rights, all the small deltas. We sum them up. That's what the sigma stands for. And we convert that into the digital domain. We can actually do that much faster than the actual signal is, and then demodulate it. We bring it down, we downsample, and we decimate, and we can get accurate representation. I hope that has helped you.
Excellent. Thank you. So your thesis focuses on achieving both high resolution and low power consumption. That's correct, right?
Yes.
Yes.
Those are one of the challenges that I work on.
So, two goals that often compete with each other. How do you approach that trade off in your research?
Well, in our field, especially in analog and mixed signal design, we say there is no free lunch. So you cannot have high resolution and low power consumption and low cost everything. It does not work like that. So our work is to actually find out techniques that can leverage on some existing features of a technology and then try to maximize both, in this case, high resolution and low power consumption. So my expertise is to find out what are the qualitative, I'm not saying quantitative, just qualitative trade-offs that I can make. Based on that, I can figure out certain techniques which can leverage the properties of the systems that I work on.
Electrical engineering sits at the crossroads of hardware and intelligence. How do you see this evolving in Europe's transition towards smart and sustainable technologies?
I think it sits at the very core of it. Electrical engineering is a very broad term. Me, I only work in this small field of sensor interfaces. I just call it small, pun intended. It is not that small and is also very important. However, electrical engineering also means high voltage engineering, for example, and power grid of a country, of a national entity. And that means the more we can get from electrical engineering, the more we are close to a smart and sustainable world. And it is actually our duty as young researchers to enable these. We want to build a brighter future, a more sustainable future for the generations to come. That is one thing and one challenge that we have faced as our generation.
ETH Zurich is often seen as a model of European engineering excellence. What makes its research ecosystem so effective for innovation and technical depth?
I am pretty sure that from 1855 until 2025, where we are today, the culture at ETH Zurich has actually worked in favor of research. It means one professor comes, does a great research in his field, but he not only stays with his own research, he also educates the newer generation. And from generation to generation, ETH Zurich has accumulated a huge wealth of research capital. So the culture where the younger students, bachelor students enroll in, and what they see, how research is being done, and they get to meet the professors in person. They get to talk with them. We are quite local. We can talk to our professors in their free time. It is this exchange and the interpersonal communication culture that we have at ETH Zurich that I have valued a lot. I'm sure there are also other factors that have played a role, but this is something that has stuck with me.
Having studied in both Lucerne and Zurich, how would you describe academic and cultural differences between these Swiss institutions?
Well, in Lucerne, I have studied at Hochschule Luzern, or in English, the University of Applied Sciences of Lucerne, and in Zurich at ETH Zurich, which is Swiss Federal Institute of Technology, Zurich. We can say the latter is a university in the classical sense of European universities. The former is a University of Applied Sciences. So what is that? Especially in German-speaking countries, Germany, Austria, and Switzerland, we have these types of institutions. They are actually targeted more for people that have done an apprenticeship, studied and learned their trade, and went on to further expand on their expertise. Then they end up in something which sits actually between the practical world and the industry and the academic world, the university. So there's University of Applied Sciences is on international level, it is mostly recognized as a university as well, but we have had many more practical problems to solve, many more projects to solve. Most of my colleagues there, they also worked part-time or have had their fair share of experience in the industry. Also, I remember that our thesis projects, they were also in cooperation with local industrial players. So it is more towards It is less geared towards a research-oriented schooling, as more to a education, becoming an engineer, more a professional education.
Switzerland, while not an EU member, is deeply integrated in Europe's R&D ecosystem, from horizon programs to technology transfer networks. How does this influence your work or funding opportunities?
Well, as a PhD student, I cannot much comment on the funding opportunities. That is something that the leaders of the research group take care of. So I can focus on my own work. But the way I see the influence of this, of the European integration, is that we get to work on multinational projects. We also have to exchange with many other European researchers and fellow PhD students. So that brings a cultural richness to our world.
From a researcher's perspective, do you see Europe maintaining a competitive edge in semiconductor design, microelectronics, and embedded systems compared to Asia or the US?
That is a very difficult question. I'm sure everyone who follows these topics in the international news knows the competitive edge of Asia and the US. But the competitive edge Europe holds is not that much known. The largest semiconductor manufacturing company, TSMC, uses machines from ASML, a company based in Europe, in the Netherlands. While ASML is also a quite international company, they also work with lenses from Zeiss in Germany, for example. But all these companies, especially in the electronics industry, I would say, have become so international. We work together with the whole world. Researchers from Asia, US, Middle East, Australia, basically from all continents, I would say. So I cannot say that there is one continent or one group of countries which can hold a competitive edge anymore. We are so advanced in technology, we need international cooperation. We need an international culture where we can research on the same fields and on the same problems to push for the limits that physics has against us.
Energy efficiency and data precision are now political topics as much as technical ones. How can engineering research like yours contribute to Europe's digital sovereignty and green transition?
That is a good question. While I cannot comment on energy efficiency and data precision in particular, I will try to answer your question in a more general way. Engineering research is, sometimes I imagine this as a bucket where countries or governments can dump their money in. And sometimes something good comes out of it. But if something good comes out of it, it will be very good. It can revolutionize the world or solve many problems. And that's why I think engineering research is something that is very, very worth investing. We need to value this and we need to support this. It certainly is the key to digital sovereignty and green transition. But how that will happen, I cannot comment on that. I don't know. We will see.
You will see, yeah. Fair enough. So I wonder, what's your personal experience of living in Switzerland as a researcher? And perhaps could you please tell us maybe your background since you were a childhood and how you end up in Switzerland and stuff, because most of us in the audience have no clue. Especially I'm asking this question in terms of collaboration culture, like work-life balance or the broader European research community. You can extend on this topic as well.
Well, I was born and raised in Switzerland as a child of parents with a migration background from Turkey. Specifically, in Switzerland, we have a particularly high share of people with a foreign background. And I think that was also one of the motivations for this culture to become a collaborative culture. We get in contact with them. For example, at school, there is a festivity and everybody has to bring food from home. My mother used to make her famous kısır, and all the other parents would ask my mother and me for the recipe for that. I think working together on something, on a project, on a festivity, on an event, or a research project, together with people that have different backgrounds, can only flourish if we have this collaborative culture, if we can communicate well with each other. But that also requires quite some creativity. And I am very sure creativity cannot work without work-life balance. We need our time off. Fortunately in Switzerland, we have our mountains and our nature, which are famous in the world. And we get our time to hike and to enjoy nature and to get our inspiration. I'm sure maybe you have also watched the Oppenheimer movie.
Yes, yes.
Albert Einstein is famously met there in the movie at a lake.
Right.
We have plenty of lakes. I hope maybe somebody else can also go to a lake and get great ideas or inspiration. I think nature is something that inspires humankind.
So you also enjoy hiking and you get inspiration from nature. Is that right? Yeah.
Yes, that is correct. I get my inspiration mostly from nature and also food. I think food is actually something between culture and nature. We try to use what nature gives us to turn it into something delicious, to turn it into something which can blow our minds. And creativity is a key part of that. I'm sure everybody who has cooked more than 2 meals will know what I'm talking about. But we also need to get our inspiration from others. And I think collaborating and seeing, oh, my neighbor cooks this dish in a different way. My neighbor thinks about this project in a different way. I think this is something that we can profit from. And I think research flourishes only that way.
Finally, Özcan, if you could define the European engineer of the future, what values, skills, and mindset should that person embody?
Here I would certainly say being an open communicator is something that is very valued, especially in the future. We need to be able to convey our ideas and to understand other ideas. And we need to be able to make something creative out of that, to form a symbiosis of what I think and what others think. As for skills, I am sure that it is getting more and more demanding. We need to be able to code something, to build models. We need to be able to communicate in different languages. And the mindset that one should embody would be to be open and trying out something new. I sometimes think of engineering researchers as of more sophisticated children that play with bricks and toys. I'm sure everybody of us has had a childhood where we played with toys and we tried to build certain things and we imagined. We just held a piece of wood in our hands, but for us it was a car or a rocket. And that imagination has driven us to put that brick of wood onto a table and lifting it up so to simulate a space rocket launch. And I hope that is a good metaphor for how we can actually work as engineers.
Absolutely, absolutely. Well, thank you very much for your time, Özcan, and thanks a lot.
Thank you, Aybars.